the test is not Thursday, right? So that's good news. So you've got time to fix whatever it is that went wrong here, right? Let's talk about it. So first of all, the first problem is find the domain of the function in interval notation, right? So the issue is, what x does this formula not make sense for, right? So we have to avoid division by 0, so we need x plus 7 not equal to 0 for this formula to make sense. In other words, x is not equal to minus 7, so this tells me that the domain of f of x is minus infinity to minus 7, unioned with minus 7 to infinity. Well, I asked for the answer in interval notation, so that's what that means. Now, if you wrote the answer in a logical but different way, I'm still going to give you some partial credit, right? But this is the correct answer. Let's see here. Problem 2. Let's look at how to simplify that, and then I'll be able to answer the question that's in the statement of the quiz. So let's see here. This is the first thing gives me x to the 2/3, and then I'm just going to write the next one as square root of x times the square root of y, and x to the minus 3, y squared, square root of y. Right. So at this point, you see I can cancel square root of y and the square root of y, which is kind of nice. All right, so if you don't understand the first step, just to clarify, the cube root of x squared is x to the squared to the 1/3 power, right? Which is x to the 2/3 power. That's where that is coming from. All right, and then so what we have is we have x to the 2/3 plus 1/2. That's from this square root of x, right? Plus 1/2, and then plus 3, because that 3 in the denominator, when I bring it upstairs, it becomes from minus to plus, right? And how about y? I have y to the minus 2. All right, so if I add those fractions, I get 25 over 6, y to the minus 2. Now I said, find a and b such that what? I said set this equal to x to the a, y to the b, right? So what are a and b? A is 25 over 6, and b is minus 2 in this case. Okay, so that's problem 2. Problem 3, to simplify this, what I'm going to do is I'm going to multiply by x over x. So the instructions were simplify, right? So to simplify, we want to turn it from being a compound fraction just to being into a simple fraction, if you will. So this is x times 1 over x minus 2x, distributing the x upstairs, x times 1 over x plus 3 times x, distributing the x downstairs. By the way, I am posting this solution that I'm going through on Blackboard. It should be posted at noon, so if you don't feel like trying to madly copy down everything I'm saying right now, if you just want to focus on what I'm saying and don't write it down, you can do that. I am posting the solution. It's already posted. It's supposed to be up there at noon. So anyway, this is 1 minus 2x over 1 plus 3x. There you have it. I think that's about as simple as you can get here. The next problem is considerably more interesting because it's got a lot of factoring that you need to do in order to make it through. So the factoring here, let's do it. X squared minus 16 is x plus 4 times x minus 4. All right, that's just from this x squared minus 16. Then I can factor a 4 out of x squared minus 4 to give me x squared minus 1. I'll just do that much on the numerator to start with. Downstairs, I can factor a 2 out. I've got a 2 times x squared plus 3x minus 4 times x minus 1. All right? So I'll do that much in my first step. Of course, I'm not done, right? Because I can further factor the factor in the numerator and also the denominator. X squared minus 1, how's that factor? So I'll bring the 4 out front. I've got 4 times x plus 4 times x minus 4 times x plus 1 times x minus 1. So I'll underline that in red. What I did was just break this out into these two terms, right? Because x squared minus 1 factors like that. Can you guys tell me how the term in the denominator factors? I'll make it purple. How's this factor? I heard an x. It factors nicely, I'll tell you that. How does it factor nicely? A negative, what'd you say? I got to somehow get an x squared plus 3x minus 4, right? How about if I use plus 1 and minus 4? Would that work? Well, that would give me a minus 3x in the middle, right? So I should go the other way around. I should try plus 4 and minus 1, right? If I do that, then that will give me 4x minus x, which gives me the plus 3x. And of course, I get the minus 4 and the x squared from multiplying those two terms out. So in other words, I'm just factoring that thing into those. And at this point, you can see everything's completely factored, right? Once everything's completely factored, then the reduction should become clear, if there is one. And there is one here, right? Because we can cancel this guy and that guy, right? The x plus 4. Wait a minute, my bad. The pluses should cancel, right? Not the minus. What's wrong with me here? So this one and this one cancel, right? The x minus 4, it's minding its own business up there. It's left alone. Let's leave it there. All right, there you go. Live in peace. All right, but on the other hand, it's not looking so good for the x minus 1. That's canceling with that one, right? And so there we go. I think that's all we can do. 4 over 2 is 2, right? So the answer is twice x minus 4 times x plus 1 divided by x minus 1. Now, it is, of course, possible to make partial progress on this problem and get partial credit, but I think that's as simple as it can get. All right? There's a lot going on in this problem. It's definitely possible to get partial credit here. I'm much more of a stickler about getting the answer precisely correct on this problem, right? Yes, there are also subparts, but I don't tend to give a lot of partial credit on these kind of problems. Like, I want you to be careful about this and get the correct numbers. This is a skill you need to acquire, because this particular kind of manipulation continues to be an issue after this course and every other math course. And not even if you go, I mean, yeah, sure, if you go to pre-calculus, it's going to be an issue. And I know most of you aren't doing that, right? But whatever other math course you use, if it's got any kind of equations at all, this kind of simplification and identification is always an issue, right? Even if it's just like, the kind of science we teach to middle schoolers, like a general science class, it still has square roots and things like that in formulas, right? So we need to understand what this notation means. But anyway, just a comment. My wife teaches a course online which doesn't have a math prerequisite, but people still need to add fractions to do the basic physics stuff that she has in that course. It's always an issue. A lot of her students are future or current pilots. It's a little bit disconcerting, but I've always thought of a pilot as a person who's like pretty good at math and has a good technical head on their shoulders, right? Maybe not. See, I think implicitly I have a bias that pilots are astronauts, and those are actually two rather different things, Okay, so here we go. We've got 3x plus 25, x to the 4th, minus 90, x to the 6th, all divided by 15x squared. So if we've got the addition in the numerator, then we can break it up into a sum of fractions, right? If the addition was in the denominator, we can't do that, right? So here, this is 3x over 15x squared plus 25x to the 4th over 15x squared minus 90 x to the 6th over 15x squared. 3 over 15 is 1/5, so this just gives us 1 over 5x, right? Because x over x squared simplifies to 1 over x, and that simplifies to 5/3. 25 over 15 is 5/3 x squared, because x to the 4th over x squared is x squared again. And then 90 is 6 times 15, so that's giving me minus 6. X to the 6 minus 2 is 4. So there you go, that's that one. Problem 6, we have the cube root of minus 64 x to the power 9. All right. Now this one, how's it going to go? So we can use like properties of the cube root. The cube root of a product is the product of the cube roots. So this is the cube root of minus 64, and then the cube root of x to the 9th. In exponential notation, this is that's minus 4. You can try your calculator if you like. The cube root of minus 64 is 4, because minus 4 cubed is 64, minus 64. And then this is x to the 9th to the 1/3 power. 9 over 3 is 3, so the answer is minus 4x cubed. The next problem, problem 7, we're asked to rationalize 8 over 3 plus the square root of 7. So what you do is you take this and you multiply by 3 minus the square root of 7 over 3 minus the square root of 7. This is the standard trick to rationalize the denominator. We multiply by what you might call the conjugate of the denominator over the conjugate of the denominator. So this gives me 8 times 3 minus 8 times root 7 divided by 3 times 3 squared minus 3 root 7 plus 3 root 7 minus the square root of 7 squared, which gives me 24 minus 8 root 7 over 9 minus 7. Notice that the middle term's canceled. That's the whole reason for multiplying by that conjugate over the conjugate term. It makes the square roots go away from the denominator. That's the whole point. And so that's 2. 9 minus 7 is 2, right? So this further simplifies to 12 minus 4 times the square root of 7. Like that. Now we get to the interesting part of the quiz, right? So the last batch of problems, they're not simplifications, right? They're solving equations, okay? And I think that your test will probably be a little bit even more lopsided on the side of solving equations. I didn't put as much of that on the quiz because I just started doing that in class. So admittedly, it's like, you know, well, this is why I previously had the quiz closer to the test so that you had more time to prepare. But thinking about it, I think it might be better for you to have less time prepare for the quiz and more time between the quiz and the test, so I changed it up. We'll see how it works, you know. So here we go, problem 8. I mean, I'd like for all of you guys to do better on the test, pretty much, with a few exceptions. You know who you are. I'll say it this way. I mean, there's no one who made a bad score on the test who I want to continue doing badly. Like, I don't hold any of you in contempt. Like, I have no spite, you know, no animosity. Like, none of you offend me personally. I just need to see better math for a better score. That's all, you know. That's not always the case. I mean, sometimes there's classes where there's just a particular student who, like, he got what's coming to him, you know. But none of you guys are like that, so. Actually, those kind of students are pretty rare. Usually those kind of students get called out by other students in class. Like I had this one student who used to talk during tests under his breath. Just this incessant mumbling during tests. And, oh, is somebody do that in here? Huh. Is this another class? No, it's not. Okay. Anyway, so like in the middle of the test, this like I had this one student who was about my age in the class for whatever reason, and he just in the middle of the test just like turns around at the other guy and goes, "Shut up, just quiet." Just like, thanks. I should probably have done that, you know. So anyway, multiply this by 21 is what I would do because I hate fractions. And that gives me 7x minus 3x equals to 21 times 11, which I could figure out, but I'm just going to leave it as 21 times 11 for a second, which gives me 4x is equal to 21 times 11. Fine, what is it? It's 210 plus 21. 231. So x is equal to 231 over 4. There you go. Problem 8. Some people got it? I hope some people got this one. You were in the right direction. Just the fractions got to you. Yeah, this will happen. Okay, so, and there's something I should, you know, this one's kind of a pain, but you could check your answer, right? So if I check my answer, what's it look like? Allegedly, 1/3 of 231 over 4 minus 1/7 of 231 over 4 is what? It is 231 over 12 minus 231 over 28. What's that give you? You can punch that into your calculator, see what happens, right? You definitely have time to check your answers on the test, right? I mean, my test is a little bit longer than this quiz, but not a lot longer, so you have time to check your answers if you want to. Now, and that's one of the reasons it's friendlier for me to give you more equations and less simplification, right? How do you check your answer in a simplification? Pretty much the only way is to cheat off a smart person, right? But, or I should say cheat off a person smarter than yourself. I mean, like, it's not important that they're absolutely smart. The important thing is that they get more answers right than you on the average, right? If you're going to, as a general point, right? Don't cheat. But anyway, what's this work out to? It better work out to 11, otherwise I did something wrong, right? Uno momento. It's 11. All right, well, I see you're holding a calculator in your hand, so cool. Which is good, right? Because that's what's supposed to happen. Now here, to solve this one, we can do cross multiplication, right? So we got 5 times x plus 1 is 4 times x plus 2. Then we distribute, right? So this gives us 5x plus 5 equals to 4x plus 8. Now, I isolate x, right? So I'll subtract 4x from both sides. And I'll subtract 5 from both sides, right? So this gives me 5x minus 4x equals to 8 minus 5. Hey, 5x minus 4x, well, that's x. That's convenient. So there it is, x equals to 3. Let's check our answer. So is 3 plus 1 over 3 plus 2, that's equal to 4 over 5. Is that equal to 4? Hey, it's equal to 4/5. Woohoo! All right, it worked. Right? Checking your answer here is a good idea. If it doesn't work, what do? Try again, right? And I would encourage you, when you try again, don't just erase your work. Like, work it to the side and like put a line through it. And when you work your work again, rather than erasing all of your old work, just put like a line through it. That way, if you run out of time or something, you still have something I can give you partial credit for. If you just erase everything, and then I collect the test in the middle of that, you've got nothing, right? So it's a good practice. Like, don't erase everything. Just work it off to the side, and then you might also. Anyway, I think that's just a bit of advice, because I see some people that they check their answer wrong, right? And then they erase everything, but they're erasing the right work. So then, I don't know, be careful what you erase is all I'm saying. Okay, so problem 10. Problem 10, here we have the cube root of 5x plus 19 minus 2 equals to 1. So the first thing, if you have an equation involving radicals, is isolate the radical. So this gives me the cube root of 5x plus 19 equals to 3, right? Because 1 plus 2 is 3. Now, the natural enemy of the cube root is the cube. So just cube the equation, all right? So the cube root of 5x plus 19 cubed is equal to 3 cubed. What's 3 cubed? Well, 3 cubed is 27. And so what we have then is we've got 5x plus 19 equal to 27, which then gives me 5x is equal to 27 minus 19, also known as 8. X is equal to 8 over 5. And again, you can check your answer here, all right? How would checking our answer look like here? So notice that if we took the cube root of 5x plus 19, that's the cube root of 5 times 8 over 5, right, plus 19, which is the cube root of 8 plus 19, which is the cube root of 27, which, by the way, is 3. So if the cube root of 5x plus 19 is equal to 3, then it's going to solve that equation, right? Because you get 3 minus 2 equals to 1. So that's good. Some checking answer. And so then the final problem in the quiz, a little bit more involved, right? Let's do it. Do these problems always have to have answers? No, they don't. So here, problem 11, and I don't just mean because you didn't do it. I mean, like, even if you had all the time in the world to work on it, it might not have a solution. And I can explain that geometrically to you here in a minute. But so here we go. Here's the problem. Isolate the radical. So you got square root of x minus 6 is equal to x minus 8. Square both sides. That gives us x minus 6 is equal to x squared minus 16x plus 64. That's a quadratic equation. How do we solve quadratic equations? We solve quadratic equations by putting everything on one side and either using factoring, completing the square, or the quadratic formula, right? So put everything on one side. I've got x squared minus 17x plus 70 equals to 0. Well, that factors. That's x minus 10 times x minus 7. So my solutions seem to be 10 or 7. Now I need to check my answer, right? Because this problem, I squared the equation. Remember, when we square the equation, we may inadvertently add extraneous solutions, which are not in the solution set. So let's try it out. X equals to 10. I get, well, let's look at 8 plus the square root of 10 minus 6. What's that equal to? 8 plus the square root of 4, also known as 8 plus 2, 10, right? That's good. So we have, yep.
Can we go back to, like, how did
Yeah, sure. So what I did was I add 6 and I subtracted x. I am going fast at the moment because, I was trying to get you out of class early, I guess. Maybe that's not a good reason, but anyway, but that is what I did. Does that make sense? Yeah. So like I said, the larger goal is putting everything equal to 0. So you either put everything to one side or the other, and I just decided to keep things where x squared is always positive because nobody wants to factor with the minus in front of the x squared, right? So wherever the x squared is, I move stuff over there. And so what I've written in 10, what I've written in red at the bottom shows that 10 is indeed a solution, right? So because it solves the equation, right? When I plug 10 into here, I get 10 equals to 10. I mean, great. How about 7? Well, what is 8 plus the square root of, 7 minus 6? Well, that's 8 plus the square root of 1, which is 9, which of course is not equal to 7, right? So this right here is extraneous. Extraneous solution. In other words, it's not actually a solution. Now, I haven't talked much about this, but I probably should. Can you understand these problems graphically, like what's going on? So a couple things. One is that if we have y equals to the square root of, say, x minus some constant a, what that looks like is like half a parabola. It just opens at a and it goes like that, right? So that's what that looks like. On the other hand, if I had y equals to the square root of, say, b minus x, all right, then what that would look like is a parabola that starts at b and it opens this way. Graphically, that's what those are, right? So if you have an equation, say like, suppose you look at something like the square root of x minus 2 equals to the square root of, 1 minus x. It seems like you could solve that, right? Because you square both sides, right? But can you? I mean, so in this case, you could think of a equals to 2, right? And this would be b equals to 1. So if you graph those both on the same axis, you've got the one that starts at 1, it's going like this, right? You got the one that starts at 2, it's going like that. Is there any point of intersection for those two graphs? There's not, right? So I can tell you without doing any more math that that doesn't have a solution. Even though, if we square it, what happens? Square both sides, you get x minus 2 is equal to 1 minus x, which gives us 2x is equal to 3, which gives me x equals to apparently 3/2, right? But what's the trouble with x equals to 3/2? When you plug it into the right-hand side, you get 1 minus 3/2, which is minus 1/2, right? Square root of minus 1/2, that's a complex value, right? So in this context, that's not allowed. So when you're working with problems with square roots, you can have no solutions. You can have one solution. It just like, you can start thinking about what are the different ways these graphs can intersect each other, and there's like all kinds of different possibilities, actually. It could even happen that these quadratics end up giving you two solutions, both of which actually are solutions. So you do need to check the answers that you come to. You can't just assume one of them works and one of them doesn't. That's just a quirk of the examples we've looked at. All right? So just a warning, I think your homework has more variety in it, right? And so I would expect that the test reflects some of the variety in your homework. But that's it for today, guys. So.